Welcome one and all to this 5th episode of D&D with Mike
and Zoe.
And today we are going to work on enemies a little bit. We're going to create our first enemy. We've been deliberating during the afternoon what type of enemies we would like. And one enemy we want is a enemy that spawns somewhere and then walks about trying to hit you, so chases you, and then blows up.
Mm-hmm.
Yeah. So let's begin doing that. Number one, we're gonna need various pieces. We got a prefab as a player, which is a decent prefab to start from. So let's duplicate the player and rename this one bomb or enemy bomb. Let's drag him in. Hello. We're probably gonna make it a little smaller, but we'll worry about that later. So first of all, this one does not have a player script. That's removed. All right, because it's okay. So structure, model. There's the model, and the sword holder. I don't think we need anything to do with swords. And we don't need the sword holder. We need the model to be, let's make it a little smaller. Well, I mean, the model itself will be made smaller, so let's leave it as it is for now. But we're going to give it a material just so we don't get confused. There's no player material, which is interesting, and we're starting to have a bit of a mess here. So let's create a new subfolder. Name this one map. Hit enter. Now we're going to drag all of these in. So bricks, dirt, granite, grass, blah 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 blah. All of these I think are map. Now let's create another folder. Rename this one to enemies or something. Sorry. There'll be a new material. You can call this one bomb. What?
Your yawning was funny.
Over.
To me.
So bomb, just make it dark, probably some kind of dark blue, there, something like that. That'll do. It doesn't really matter right now that it's as simple as it is. It'll do. Okay, now let's see. So that's it for now in terms of model, structure, etc. There's a target that it would be aiming at. I don't think we need that at all. And that does it. That's our little enemy for now. So the enemy bomb needs a script for the enemies. So script, create, call this one enemy bomb. That went badly. Wait, and then hit enter. Okay, enemy bomb goes on enemy bomb. Can't add a script while I'm compiling. Okay, now you can. Drag it all the way to the top. Okay, enemy bomb, drag it all the way to the top. Thanks. I'm not a huge fan of the new prefab system.
Oh.
Yeah, people swear by it, but I'm not convinced at all. I find it very annoying to use. Almost every case, it's annoying. I think when you have many to deal with, it gets better. But like this, no. How'd you do it? Double F, I think. Yes, okay. So here we go. There it is. It's got a model. It's got everything. It's got a script. Let's open the script. Let's delete all of this. Put this at the top. And we're good. So, save. Now, we're going to have to decide whether the enemy is going to be aggressive or not and what it's going to do. So, because this is an adventure game, you're going to have enemies all sorts of places, right?
Yeah.
And so they will have to decide whether they're angry at you or not. So we're going to create a private bool aggressive with 2 G's. Or wait, no, I'm wrong. 1G. I'm almost sure you're correct. 1G, but let's go check. Right? When we have doubts, we check. Type define, colon, and type aggressive.
And the way I wrote it?
Yeah. Yeah, it's 2 G's. Define aggressive. Yeah, 2 G's. That it was right. Put another G. Save. Okay, so if the enemy is aggressive, it'll do certain things. Now, how should the enemy behave, the bomb enemy behave while it's not aggressive?
Just walk around the place.
Well, that's easy to say. How does the enemy know how to walk and where to walk?
Mm-hmm. You're right. Stand still.
Well, yeah, we could
Like
make
a
the enemy...
Goomba.
The Goombas don't stand still, they walk. But this type of enemy is a bomb. We could make it just like Zelda, which is a bomb that stays on some kind of like spawning point, like the flowers, and just waits there. We could do that. Otherwise, if we make them walk, we're going to have to give them walk points, which is going to be interesting because we're going to... so basically it would be patrolling an area.
Yeah.
We could do that. We could patrol an area. But obviously this is going to be part of level design.
Mm-hmm.
And it's actually not going to be very easy to do this because it's not only not very easy, but the way our game is set up, I don't even know it's possible. If our level design is done the way we're doing it, which is through a pixel map, right? It will be impossible for us to tell the enemy where to go and what to do unless we do something intelligent. Like, for example, raycasting around, deciding if there's enough room and then going that way. Is it done randomly? Is it not done randomly? Etc., etc. It becomes quite complicated. Unless we can count on some kind of unique ID for each enemy. So if you take, for example, our map, so under the textures, right, we got our GIMP map. If you go to the map, you know factually that whatever's at the bottom left is first. The map goes like this, right? So if you put an enemy spawn point, say here, right, you'll know this will be the first one. If you then put another here, it'll be the second one. Problem is, if you then put one over here, this one's the first one because it's further down, right? So the level design will become quite annoying if we're not careful with this type of stuff.
Yeah.
I'm thinking there could be other ways, like we could create an overlay map that is exported as a separate file where the color analyzed could have some sort of variance as it progresses. So you put, say, one dot over here, and there will be one spawn point, then another dot over here, there will be a different spawn point, but you change the color of that second dot to a different color, slightly lighter or something. But I think that would be a massive pain. It would probably be better to make the enemies sort of figure out their paths on their own. And it's not going to be an easy task. Let me think. So the bomb could be doing some patrolling in a straight line. And we could raycast which line we want. And we could do one of, say, 8 directions. And pick the one that doesn't raycast against anything. And if it raycasts against something, then it patrols for less distance. Something like that. I don't know. Alright, so in that case you want a serialized field, private, float, and this one will be patrol distance, patrol max distance. So a semicolon, it's 1L patrol. Save. Now one thing we're definitely going to want is we're going to want to register. Well, no, we just need an angle, really. Yeah, so we're gonna put another serialized field. So serialized field, close, private. Float, patrol angle. Yeah, save. Okay, so we got patrol distance and patrol angle. Then serialized field, private float. Float. Speed. Well, this would be put speeds with plural. Semicolon.
The one we want an array?
Yep, save. So we're gonna have speeds because one for aggression and one for normal. And when the enemy is in aggression, it will just start chasing after you. And we'll decide how to do that. We'll probably make it a little faster. But so one thing we're also gonna need is some kind of detection distance. So go serialized field. Close, private, float, detection distance. Semicolon, save, and that's it, probably, I guess. Yeah, hit enter twice. So when it spawns, it should have some kind of setup. So you go void, setup, open, close. Save. Now a few things we're also going to need is we're going to need some some variables that are sort of just used while it's alive. So we're going to need a position to spawn it. So and you go with vector 3 or private, obviously private vector 3. Technically not saying anything makes it private, I think. So private vector 3 start position or yeah, I like to call them S-pos. We'll do S-pos, capital P. S-pos, semicolon, then enter. Private vector 3 E-pos. E-pos, semicolon, save. Now we're also going to create a private coroutine. Yeah, space, now capital COR underscore patrol. Lowercase, sure, that's fine. Patrol, semicolon.
I do it like this.
I know. And then another coroutine, private coroutine. And this one is core aggression. Two G's. Semicolon. Okay, right, so we set it up. The first things we're gonna have to calculate are the start position and the end position. The start position is fairly easy. We should receive it from the outside. So here say vector 3. And go S pos, S position, just position. Positing, position. Yeah, and here you can say S pos equals position. So we save it because our spawner will give us where we are. Semicolon, save.
Yeah.
Okay, we could also say spos equals this position, but it's fine. Now, epos needs to be calculated, and the way we're going to calculate it is by casting a ray in the angle. And wherever we hit a thing, if we hit a thing, we are going to then go that ray minus a certain amount distance, etc. So this will not be too obvious. So type ray. Yeah, space. Now call it ray equals new ray open round. So it needs this. It needs an origin and a direction. The origin is easy. You say position or spos. Now comma. The direction. Oh boy. So.
I'm guessing vectors.
Well, yeah, obviously it's going to be a vector 3. The question is, how do you get to that vector based on an angle? I don't remember at all. Try vector 3 dot, try from angle something. Ah, wait. No, we could do a vector 3 dot forward. Yeah. And now to rotate it around that angle. It would be... I don't know. I don't know. Let's go and look for it. So type unity. Go rotate vector angle. Hit enter. So rotating a vector by your Euler angle. Okay. Transform Euler angles. Rotate the vector quaternion angle axis. There it is. Okay, so I think it's this one. So you multiply this times quaternion dot type axis angle axis open round. Now it wants an angle. That's our patrol angle. Copy that, paste it, comma. And
an axis.
Then the axis is vector 3 dot up. Yeah. Close round and close it again. Semicolon. Okay, why is it not happy?
Operator cannot be applied to operands of type vector 3 and quaternion.
Right, so but this one should, I think, return a vector. No, it returns quaternion. So I guess you need to go dot. Wait a minute. Let's take a look here. Times original vector. I thought that's what we did. I'm a bit confused, but this should probably be unnecessary. So you would have this, but what I don't understand is this should be a direction. So it actually returns a quaternion, which doesn't make any sense. So how in the bloody world is this working? It isn't. Rotated vector, it's quaternion, times original vector. That's not possible. Angle axis does not return that. Let's see what else we got here. Yeah, there it is. So quaternion equals vector 3 equals quaternion times vector. That's what we're doing. Just wanted to point out vector does not always represent the point in space, cannot represent the direction, such as surface, normal, object velocity. For this reason, I like to talk about rotating a vector. Blah, blah, blah. Okay, well, but here they're multiplying it for some reason, and we are, for some reason, not capable of doing it, which is very strange to me. Let's try type vector 3.
Oh, type.
Vector 3. Test, whatever, it doesn't matter. Equals. And copy all of this. Paste. Semicolon. Okay, so it can't work. Now multiply this by vector 3 dot up. Doesn't matter. I don't care. So it's happy now, but not here.
Because we didn't add it. I guess.
Vector 3 dot forward. Okay. Save. I think this will work, I'm not sure. We'll find out. So now we need to cast this ray. Well, we need to find out where this ray goes. And I don't know where it goes. So the first thing we're going to do is we're going to say debug.log. Debug.drawRay. Draw line, something. Draw line, that's it. Open round. And here you're going to say array.origin. No, ray.
Oh, I heard
Yeah,
array.
Ray.origin, comma, ray.origin plus ray.direction, origin, yeah, plus ray.direction times, copy this. Paste it here, then comma, color.red, capital C, comma, and say 10F, semicolon, close round first. Save. So instead of setup, sure, we're gonna say void start. We're gonna remove this later. Yeah, that's it. It's already done.
Oh, forgot again.
Remove the word private. Save. And here simply say setup. Yeah. Vector 3.0. Dot 0. Close the round. Semicolon. Okay, so when it starts, it will do this. As long as we have one in the scene, but it's going to need this information, and then it's going to draw that ray for 10 seconds, and we'll be able to see where that ray goes.
Mm-hmm.
Alright, so there's the enemy bomb. Let's put it at 0. Let's go there again. Now patrol max distance, let's do 5. Patrol angle, let's do 0 for now. Speeds, doesn't matter for now, but we're going to have 2. One that's 5, one that's 6, I don't know. Detection distance, we're gonna say 10. I don't know. Save. And now let's see when we get this angle. Okay, should have already happened. And there it is.
Yeah, I can see.
So it's at 0 degrees. Let's grab the game and dock it here and tell it not to maximize, so we can keep on keeping an eye on this guy. Okay, now let's change the angle to 25. There it is, it's working. So now it's 25 degrees in that direction, and you see it's straight. That's what we're interested in.
Mm-hmm.
Right? We should probably cast the ray not from there, but from the center of the object, so at a height of 0.5 or something, which is fine. The rest is working fine. Let's quickly give it a test with something a bit more extreme. So 25 plus 360. All right, so this should be the same angle, just done full circle plus a bit, and it's working still. Okay, so 90 degrees should be to our right if we want to. So 90 degrees is always going to go
there.
East, right? Okay, it's working. We're good. So we can be rid of this. Save. Okay, now we said we want to cast the ray from a bit higher than the position. So here you want to say plus vector3 dot up times 0.5 float. Save. Right, so now it will lift the ray just a tiny bit.
Yeah.
Okay, now here you want a raycast hit. There it is, one down. Yeah. Raycast hit, and call this one hit. Just space hit. Semicolon. And here we're gonna say if physics two down dot raycast open run. Okay, and now it's got a bunch of this and different possibilities. Now we're gonna use our ray, so just type ray, comma, out, hit, no, space hit, comma. Now let me see here. So raycast info, max distance is patrol max distance. Start typing. No, careful, you type patrol angle. Patrol. No, max distance. You're losing all of the IntelliSense. Use it here. Patrol. There. One down. And I think, isn't there yet another possibility? Layer mask. Yes. So put another comma. And for the layer mask, well, I don't know which one it is. Do we have layer masks for layers for our prefabs? I don't know. Let's see. Wall. Oh, so annoying. You need to go in here and actually check.
Yeah.
Okay, so obstacle. Add another one. Water. Okay, this is enough for now. So this one is going to be layer mask. Right, there's this new bug in this new version of Unity that you can't see the layers. So this is wall or obstacle, that's fine. And the C is going to be water.
C.
But now that I think about it, you can never hit it. So that's kind of stupid. That's kind of daft. I don't know what we will do with this. Because we can't raycast into the sea to find out that it is the sea. Unless we change the way the sea behaves, which is something we could technically do later. Let's leave this behind for now. We'll worry about it later. But we will create in the game manager a thing for these layer masks. So game manager, right here you can do public layer mask space, and this one you can call it obstacle layer. Semicolon. Save. Alright, so now here in the game manager we can tell it which one the obstacle layer is, and we're gonna say it's obstacle. And then the enemy bomb, right here. Here you put game manager.script.obstacle layer. There it is. Close. Open. No, close one more. My bad. Open. Hit enter twice. Close. Now the way this works is it casts the ray. If the ray hits anything, this turns true.
Okay.
Okay. Ooh, we're being rated by Zorkenheimer. Thanks, Zorkenheimer. We're in the middle of doing a show with my 9-year-old daughter. The show is called D&D, not the board game. We're actually making games together. That's it. So this show will go on YouTube as of tomorrow, and we usually don't talk to our crowd on Twitch while we're doing this. we go on for another half hour now. But thanks for the raid. I just wanted to acknowledge that. Okay, so we have the ray. We're throwing it out. The hit information is going to be populated if it hits anything. So just in here, hit will become something. Otherwise, hit will be nothing. This goes for the maximum possible distance, etc. So if we hit something and we got to the maximum possible distance, what we're going to do is we're going to select the end position as where the maximum possible distance would be, minus something. We're going to decide whatever. So let me think this through. It would be epos equals, and this will be hit dot point then put a semicolon and, or no, let's do minus, and now we need the opposite of the ray direction. So it would be ray direction, no, just ray dot direction. So if the ray is going in a certain direction, we're taking the opposite direction, okay? Because we put the minus, that's already going to happen.
Yeah.
Okay, so minus ray direction, now to go dot normalized. And now you multiply this by the size of our character, which let's say is 0.5. So go 0.5 F and hit semicolon. Now another thing that we need to do is we need to put the epos on the ground. So go epos dot y equals what? Equals what? Very difficult.
Place where you finished going?
Oh, that's a fantastic answer. I want to know the mathematical number that belongs there. Come on, Zoe, this is not difficult. This annoys me because you're not paying any attention. You're just typing, right? Which is fair enough, but I need you to pay attention. I want you to learn some stuff. My time is precious. Stop wasting it. Where is the ground? How high is the ground in the game?
0.5.
No. We can't do it. How high is the character here?
1.
No.
But
the y is?
0.
Well, there you go. It's always 0. What did you expect? Right? Epos.
0.
Yeah, 0, 1.
Float.
Yes. Semicolon. Save. Okay, so 0f. We've placed it down. Now, in case we don't hit anything, so else, it means that our patrol can go as far as we want it to go. So hit enter twice, close the thingy, yeah, save. And what we're gonna do here is we're gonna say epos equals, and this would be spos plus and it will be ray direction dot normalized. You forgot the dot. Ray dot direction dot normalized. Direction and then the dot normalized. Wait. Multiplied by patrol max distance. Semicolon. Now let's see if we can understand this. The starting position, then you add the direction from your ray that you have decided to cast, which depends on your angle. You normalize the direction, which means you remove how far it goes and you only worry about its direction. So
Okay.
the maximum the exact magnitude of a normalized vector is always 1. Okay, then you multiply whatever that result is, that direction, by how far you want to go. So if the max patrol distance is 5, right, it's gonna get all the way to 5. Now we've got the ending position where we hit something, where we don't. If we hit something, we stop where we hit the thing, and then we remove the opposite direction, multiply by half of the size, which should be how big our little guy is, more or less. Right? If it won't be, we can always alter that number. One thing that's important for our audience is we are making simple code, right? This is already difficult enough for a child. That's not necessarily how I do my enemies in my games, yeah? Okay, so there we go. Physics Raycast. Okay, so this is all good. Now we got the end position. We got the end position and the start position. What we can start doing now to our little enemies, we can start making it move. So we're gonna launch the patrol. So you're gonna say void space start patrol. Now what will the patrol be? A coroutine, right? That means we want a stop patrol right here. Void.
Is that why you made the coroutines earlier?
Yes. Stop patrol. I like coroutines so they manage themselves. Okay, and then here you say I enumerator. 2 down. Patrol routine. Patrol routine. Open, close, open. Yes, save. All right, so stop patrol is the first one we're gonna do. We're gonna check if patrol is null. So go if core underscore patrol. That's the one. Equals not equals, rather exclamation mark equals null. Close, open squiggle. So if it's not null, we need to stop it. So stop coroutine, and you should know its name. There you go. Now close the round, semicolon. Alright, now you can call stop patrol when you start it.
Okay.
So if we ever have to start patrol again for whatever reason, it shouldn't happen, but no, open close round, semicolon. Now enter, and you say core underscore patrol equals start coroutine, 1 down, open round, and the routine is this, patrol routine. Open close round, semicolon. Alright, so we've done everything there is to do now. Now I've got a question for you. This is a very difficult question. I'd be very surprised if you can answer this. But should our little character lerp from one place to the other while patrolling? We have a start and we have an end. And we have a speed.
I think so.
Mm-hmm. I don't. And you know why?
Why?
Well, we can only do it if we account for the distance. The problem is the enemy we want to move at a certain speed that's constant, right? So whatever, let's say the speed is 2 or something, right?
Okay.
The problem is, what if our end position isn't at max distance? If our end position isn't at max distance but much closer, the enemy will move much faster because you're lerping. You need to readapt that speed by how far those two actually are. Now, that's something we could technically do, now that I think about it. Yes, that would be quite easy to do, actually. Let's do that. We can still lerp, but we need to store a few pieces of information. The distance, the actual distance, and the wanted distance. So let's create 2 floats right here. So create a private float and go wanted distance. Entered distance. Oops. You're gonna add the W at the end. Or now. Wanted distance, semicolon, and then hit enter and go private float, And here you can say actual distance.
I'm sorry.
That's right. Control S. Now that I think about it, it would be much more intelligent to have these created directly in the coroutine. So cut them. And the reason why that is because if we have multiple points, then we'll be able to reutilize it. Now you need to remove the word private from here.
Yeah.
Okay, hit tab once. Okay, save. So we're also going to need our typical passing time. So you go float. Passing time equals 0. 0f. It's a float.
Sorry.
That's okay. Save. Okay. And I don't know that there's anything else. So type while open round bracket true. Save. So forever. Do this forever. Hit tab here. This is confusing. Now it's better. Save. Okay, so as long as they're true, passing time is going to go up. So copy, paste, plus equals, time dot fixed delta time.
Why fixed?
There's no particular reason why we should have the update happening too frequently. Semicolon. In fact, let's go to the yield statement right away. Yield return. Return.
Hey, I spelled it right.
Mm-hmm. Nope.
Oops.
New. Wait for fix update. Open close round semicolon. So it's going to wait for the physics cycle every time. And then it's going to add that to the passing time. And here we're going to say if passing time and you go lower or equal than 1f, close round, open a squiggle, hit enter twice, close it, else, open a squiggle, hit enter twice, close squiggle, save. Okay. So, let me think. So wanted distance and actual distance needs to be calculated here every time, but also here. Let's see. So wanted distance, actual distance, that depends on the current direction. Now our character can only go in two directions, either forward or back. Okay, so at that point we need to tell it, what do we need to tell it? Which direction we're going at the moment. So for now you're gonna say int direction equals 1. Direction equals 1. Semicolon. Save. Alright, so we got the direction. Whenever we reach the end, we're gonna flip the direction. So you go direction equals minus direction. Think about that mathematically. If direction is 1, what will you get after this frame?
So if
the direction here is 1, well, here, what happens here? What will the direction be?
will it go down or up?
Just read what is written here, right? Direction starts at 1. What does it become?
-1?
That's right. What if it's -1 here? What does it become?
+1.
Minus times minus, right? Which makes plus. Exactly. So +1. That's why it's always going to work this way. Another thing we need to do when we reach here is change the passing time to 0. So you go passing time equals 0. F. And here is where we can lerp. So we're going to say transform.position equals vector3.lerp. Vector3.lerp.
But we are lerping.
Open round. Yeah, I know. That's because these things are going to help us. I just need to figure out exactly how. I think they need to be calculated here and here. once in the beginning, depending on direction actually. So cut these two, put them in here, and save. So we're gonna lerp between S pause, comma, E pause. Now this isn't always true, because sometimes we go in this direction, sometimes we go in the opposite direction. So what does it depend on?
Your direction.
That's right. So we're gonna put an if clause inside here. So here you're gonna type direction. Yeah. Direction. Hit tab. Just hit tab. Hit tab. Thanks. Higher than 0. Right here. Higher than 0. That's lower. Higher than 0. Question mark. Yeah, put a space here. S pause, colon, E pause. What this means is, if direction is higher than 0, then give me S pause. Otherwise, give me E pause. Now you can copy this entire thing.
And switch it?
Copy it, paste it here. And
switch
yeah,
it.
put E pause here and S pause here. Okay, comma, hit enter, save. And we don't have a curve, and I don't think we need one. Let's go linear movement, nice and easy. So it's simply going to be passing time. Yes, now go hit enter, close the round, semicolon. Okay, now shift tab to put it back. Shift tab. No, that's 1, not tab. Shift tab. That's better. Save. Okay. Now, the problem here is our passing time. It's not accounting for how far we are, so how long it needs to go, and also it's not accounting for the speed. So the first thing we need to multiply this by the speed. This is the speed 0. It's the speed without aggression. Okay, so you go speeds, square bracket 0. Yeah, 1 sec. Okay, so speed equals 0, or rather speed 0, save. Now, one thing that we need to multiply is this distance. We need to figure out the wanted distance and the actual distance. Now, the wanted distance is fairly easy. It's between, this thing and the other. So copy all of this. And here you're going to say equals vector3 dot distance yeah, open round, S pause, comma, paste, close the round. Oh, we don't have the ray. Save. So that's a problem. Now the wanted distance, now that I remember, it's actually a constant. It's going to be a constant. So here you can do private. Now don't do anything else after you're private. Yeah, hit enter. Space, I mean. Copy all of this. Paste it here. Semicolon. Save. And remove this float. And now cut all of this. And you can put it here. Save. Alright. Now actual distance, also now that I think about it, doesn't need to be calculated here. So cut. It would be if we had multiple points, but we don't. Type private and then paste. Okay, well, copy private. Copy. Paste. Space. Save. Copy. Okay, so actual distance can be calculated here, and it's fairly easy. Paste.
Okay.
Equals vector3 dot distance. Open round. The actual distance between S pause, comma, E pause. That's the actual distance, because we've already calculated what the end position is going to be. Save.
Yeah.
Right, now, what happens, so can the actual distance ever be longer than the wanted distance? That's the first question.
No.
But it can be shorter, correct?
Yes.
Okay, so if it's shorter, we want to go at a speed that's slower, by the same ratio of actual distance divided by wanted distance. Because if wanted distance is the absolute maximum and actual distance is somewhat less, that's practically speaking a percentage. Right? Wanted distance is your total. Actual distance is your partial. Partial divided by total. So suppose that this one is, for example, 75% of this one. The number we're going to get is 75%. Also, we want to go 75% as fast. Okay? So you can multiply this by the ratio. So you multiply this by wanted distance, by actual distance. Actual distance. Yep, there it is. And then divided by wanted distance. That's it. Put a space here. Oop. Save. Alright. So that should now work. And it's going to carry on until it runs out of passing time, which then resets the passing time and inverts the direction. Because the direction is inverted, we go from EPause to SPause instead, and we just continue. Now there's one thing that bothers me, which is it's going to look like a ping pong. Very immediate. I think that our little character should pause when it reaches the target position for a bit and then go right back. That's what I think. So let's add another serialized field here. Yeah, and go private float. And go patrol pause. And give it equals 3F. Copy. And do you remember how to wait for that amount of time? Yield return new.
Wait for seconds. Oh,
That's
yeah.
right. New. Wait for seconds. 2 down. 2 down. Open round. Paste it. Close round. Semicolon. Actually, in my experience, coroutines really like ints when they're waiting for things. So we are going to be much happier doing this. Save. So we're going to pause for just seconds, not fractions thereof. And this should already work. So it'll wait every time it reaches the end. So this should work. Let's give it a shot. Where's the enemy bomb? Okay, I don't see it moving in any direction. That's because I think we forgot to start it, didn't we? So start patrol should be in setup right here. Start patrol. So open close round. Yeah. Should we wait at the beginning too, at least once? Probably. Copy this. Wait. Copy this. Paste it here. Save. So it will wait immediately and then it will go. So it's currently going at a degree of 90. It's going a bit fast. Right, so clearly the patrol speed is a problem. Let's reduce this to 1.
Better.
Possibly still a bit fast. There, I think that's a bit better. And then when it's raging, it's going to go at 1. There we go. Okay, so 0.5 and 1. To change that, either this and then do this, and to apply it to your prefab, you need to select overrides and then apply all.
Okay.
And now you see that the bolded went away. That means it's done. Now the patrol angle, we're going to have to decide every time we want based on our little enemies, whatever we pick for him. So we've got a little patrol happening here, and we are running out of time. I don't think that we can do a huge amount more. What else could we do that fits in 5 minutes? Let's set up the a spawner. Right, so we got the spawn point here for us. Let's duplicate this for an enemy spawner. Oh boy!
Didn't count.
Didn't happen. No sneeze. All right. So duplicate the spawn point.
Good, because I was in the microphone's face.
Duplicate. The
Oh,
microphone doesn't have a
okay.
face. Okay. So spawn point and call this one bomb spawn point.
No spaces.
No.
Are spaces actually allowed?
Yes. Daddy doesn't like them. Okay, so bomb spawn points, we're gonna leave everything alone for now. But we're gonna need information. So first of all, our legend doesn't have something for bombs. Alright, so for a bomb, let's do a simple red. Sounds pretty good. I'm gonna put it in the legend. Okay. Now here, new layer. Okay. Call this a bomb spawn point. Hit enter. Okay. So I'm gonna put a bomb in here. Maybe one over here. And then one over here.
Around the fortress here.
Right? So we're gonna give them all 90 degrees, but we wanna see how they behave. Well, maybe this one not. Now remember, we got a problem of order, right? So based on the order, we're gonna have to somehow figure out which one is first. And it's going to be very difficult based on our architecture, the way we're doing things. It's going to cost us later, for sure.
Oh.
So unless we prepare different prefabs or something clever, this is going to be ugly. Okay, so save, export, map PNG. Here we go. Now back to Unity. Enemies, blah, 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 models. No, what are we doing? We need to go to game manager, I think. No, map. So map has a new one called bomb spawn point. Save. Just save. Okay. Yeah. Now we need to set everything up. So inside the world, you've got 6 colors. The next one is pure red. At least I think it is. I don't know. It is. Okay. So we just go to no blue. Yes, red. That's it. So in the prefabs, we've got the bomb spawn point. Like that.
Mm-hmm.
Map containers. We need a container. Duplicate this one. Type the word bomb here in front. And remove this. Alright. Now in the world, we're going to feed it this. Map rotations. So for the spawn point, we have a -1. We're going to leave this one -1 too. Even though I technically think any would work. Maybe -1 means random. Yeah, I think so. Okay, so save.
How will it look like?
Hmm?
How will it look like?
Identical to the current spawn point.
Oh.
Yeah, because we don't have a particular prefab for it. But this should already work immediately. And we're going to delete the enemy bomb. Now what we're going to need though is a script list of some sort that will go through all of our spawn points and tell it which bomb it should use. So for that, we should possibly create a small struct or something for the type of enemy and the information, but that becomes difficult. I think a list of bombs probably. Yeah, I think that would be okay. We can try that. I'm not a huge fan of this. Okay, so what you want to do here is you want to say serialized field. Let's try and be quick so that we so private, and you say bomb. What do we call it? Bomb something. Enemy bomb. That's the one. List, by the way. List. Yeah. Open of type enemy bomb. Enemy bomb. But it has to be spelled right.
It also has to be capitalized.
Hey, capital B, OMB, close the of type, space, list underscore enemy bombs. No, it's lowercase l.
Got next to the cars.
Enemy bombs. Okay, and now that's right. Now, first things first, nothing. After we have started, loaded the profile and whatever it is that we need to do, we're gonna go through the list of enemy bombs and spawn all the enemies. So here go. Public void. Spawn, call it entities or something. Spawn entities. Zzz. How modern you are. Open, close round.
What do you mean
Opens
modern?
quickly. Nothing, and you're down with the kids because you spell things with a Z. Okay, so save. Now in spawn entities, let's go through the list of these. So you're gonna go with 4 and then hit tab twice. No, first type 4.
Oh.
Go 4.
Oh, that 4.
Tab.
Tab.
Copy. Paste. Dot count. Yeah, tab. And so save. And so what you're gonna do here is you're gonna say, oh, I forgot something. Actually, no, maybe this will work. We'll see. So you're gonna say, so we've got this list, but this isn't really right. Hit Control R twice and put the word setting in here with a capital S. Or setting. Yeah, save. Okay, so for the settings, we're gonna spawn a list of bombs. So let's copy all of this. This is probably also gonna be stupid. Okay, let's ignore this for now. Here you're gonna say game object. Not even actually. Copy enemy bomb here. Paste. And go EB equals. And you say instantiate. So now we're gonna need the prefab for the enemy, right? Which we do not have. And we need enums, etc., etc. So let's make it really cheap for now. Serialize field with a bracket first. Serialize field. I put the bracket myself. God. Serialize field close. Private game object. And you want to call this one enemy bomb template. Semicolon. Okay, copy this. Okay, open round. Paste. Now that I think about it, we need to have a list of the positions where we spawn. And that list is not available. It would be in the map, but I don't think we're keeping track of it. So it's simply not going to be possible. We're going to need to do this next time. We can't do it this time. So let's comment all of this out and call it a day. Save. Or select all. One or the other, really. Control S.
Click, please, so I can...
You can Control S even without clicking.
Oh.
Alright, so well, we're done for today, but here's what we did. To recap, okay, we're gonna take our little prefab of the enemy bomb and just sort of put it somewhere just so everybody can see how it works. And we're gonna move it a little bit, like here and here or whatever, and we're gonna give it an angle of 25 or 15 because I pressed it already. Now if we press play, our little bomb fellow should move up into us eventually. Ooh, something went wrong. Do you know what went wrong?
What?
The starting position.
Yeah. It's also bent.
No, it's not bent.
It's moving bent. Well,
yeah, 15 degrees. That's what I said.
Yeah.
Bless her. Alright, so yeah, this is working fine. The little bomb is moving in the middle of the sea. Over the sea. Okay.
I think it's under the sea, but...
Is it now? I think it's over the sea. If it was under the sea, it would be here, which I can't move.
Well, this is under the sea.
Now it's
but
under the
so-
sea, but then it's going to teleport
But the
out.
song goes
it?
under the sea.
Is it now? Would have thunk. Alright, so we're good for today. Thanks very much for watching. To the YouTube audience, goodbye.
See ya.